is a harder A-level question. Which one will give you the best outflow? The ratio is the same, 1.5 French difference.
No, they will be repeat because it's bigger.
It's just more surface area there. More.
You need to calculate the surfaces and
Yeah.
It's bigger. 1130.
Yeah. So slightly, if you have a bigger sheath, there's a slightly greater cross-sectional space, but it's marginal. But it is slightly. So, you know, probably for the difference you're seeing in the surface area, you're not going to see a lot of difference in outflow. So if you're looking at a smaller system, probably you have to have a 911 with a 7.5, be easier to pass, and you won't get much difference in terms of outflow resistance. And you can quantify all this. It's not rocket science. You just measure the areas and so on. What it does show is two things really. One is that if you try and put a really big scope in a small sheath, you're not going to get any flow. So if you put a 9.5 French scope in a 10 French sheath, it's not going to work. You're not going to have any outflow at all. And similarly, you know, if you put an 8.5 in a 9 French or so on. So down at the bottom here, these ones are not going to work. And when we talk about the difference between the sheath and the scope size, as you use bigger systems, there's a marginal benefit in terms of outflow, but it's very limited. So the dotted lines here show that marginal benefit for each difference. So probably the more important thing is the size of the biggest thing you're putting in, i.e. the sheath. And we can bench test this in our lab. And this just shows you, if we put, these are pig kidneys, we put an access sheath in, two or three things you can see here. One is the red trace is the system without an access sheath. The first thing you notice is the baseline pressure is higher, up above 20. And then these spikes are boluses of fluid.